So welcome everybody to week 3 of our Holland Computing Center June workshop series. My name is Emily and I have helpers with me today who are on the Zoom call, and you can message them with questions if you would like. Not every single one of them listed on the slide is here today because some of them helped with other weeks of the workshop. But we have here Colin, Huijin, Mohammed, and Narukta. So those are the helpers today. Thank you everybody thank you for attending, and also thank you for the helpers as well. So I wanted to include this slide, which has a list of links for today that you might find helpful to have open. Well, these aren't all links. The first one is a link to these slides. I think that it would be a good idea for you to have that one open. So you have your own copy of the slides, because we're going to be doing some exercises later where you might want to refer back a few slides to some of the things I presented a couple slides ago that might help you with the exercise that you're supposed to be doing. So I think you should have the slides link open, and you will not need this yet, so go ahead and ignore that, but later we will download that repository. So if you wanted to, for example, copy and paste that link at that point when we download it, you could do that from here, but you don't need to open this link up. The workshop website might be helpful because these slides are linked from there, as well as the slides for the open on-demand lessons that we'll be doing later. So it might be good to have that one open as well. Later, when you are working on something on Holland Computing Center resources and you have questions, a good reference is just our documentation page, and that's a great place to start to search for whatever you're looking for, or just to browse and see what we have available and what might be helpful to you. So go ahead and make sure that that's something that you know where it is, you know where to look, and you know where to find our docs. And then finally, our support email will come in handy in case you can't find what you're looking for in our documentation. Okay, so today we're going to be talking about HPC, what is high performance computing, and what is a Holland Computing Center, and what services do we provide. We'll go over the process of connecting to the HCC clusters in case you haven't done that before. I won't spend too long on it because I think everybody here should have connected at some point in the past. We will discuss how you can transfer files to and from the cluster, what process we recommend for that. There's lots of different ways you can do it, but we have one that specifically we recommend that's very easy to use and should work for any operating system. And that's Globus. And so if you already installed Globus Connect personally, you probably already saw a little bit about that. And then a large chunk of my presentation will go over just general job submission procedures. So how do you submit a job to the cluster? So I'll talk about several different ways to do that. And then finally, Mohammed will take over, and he's going to give an introduction to Open On Demand, which is a different way of interacting with the cluster. In case you're more familiar with a GUI type interface and less familiar with command line, then in that case, you might like and really get a lot of use out of Open On Demand. Okay, so what is high performance computing? Well, it's really just a way of aggregating computing power in a way that delivers much higher performance than you would get on your laptop or your personal workstation. So you're really just networking together a whole bunch of normal sized computers or nodes so that you can run jobs that are able to access multiple cores and make use of those cores to solve large problems in science, engineering, or business. And obviously that's not an exhaustive list. There's a lot of other fields of science that and even humanities that use computing nowadays and can make use of Holland Computing Center resources. And, you know, it doesn't even have to be a large problem. It could be a small problem. You could have a lot of small jobs that you want to run, or you could have one large job that needs access to hundreds of cores, or you could have just a handful of medium-sized jobs that you don't want to run on your laptop because you want to do other things on your laptop, and it monopolizes your workstation. So this is just kind of a cartoonish drawing of a computing cluster. The basic components are a whole bunch of worker nodes. Right here, just 4 are drawn, but typically there's more than 4. Well, there is on our clusters, and I'll go over the specific resources we have in just a minute. There's a login node, so that's where what you will be sort of attached to, that's where your shell will be when you log in. So when you first log in, if you were to run some kind of script that you have, you would be running it on the login node, which we don't recommend. But that's where you will access the cluster. There's also a management node that runs things like, that manage the scheduler, like that manage the cluster, like the job scheduler, for example. And then there's also a storage array attached, which gives you access to your files. This is just an image of some different size clusters. So on the left is the red cluster, which is downstairs in the Shore Center at UNL. And that's one that's used for CMS, the CMS experiment. So it's not a general use cluster. I'll talk more about our general use clusters, Crane and Rhino, later. This one is called red though, which is why it has the red LEDs on it. The bottom right is just some Raspberry Pis networked together to form a very tiny little cluster. And then the top right is just some normal desktop computers networked together with a couple of access points and monitors and keyboards to interact with the cluster. So a cluster can be almost any size. There's 3 primary HPC clusters that HCC manages. The 2 that you will most likely use are Crane and Rhino. And I mean, I won't go over all the kind of minute differences between them, except to say that Crane is the newer, faster resource, but on average has less RAM per node than Rhino. So Rhino is designed for more memory intensive jobs. But there are some high memory nodes on Crane as well. And then altogether, there's about 30,000 cores that HCC manages and 15 petabytes of storage. And we do also have some GPUs. So I won't be specifically discussing GPUs, but Crane has GPUs as well as CPUs. And you will just need to submit jobs slightly differently if you want to have access to the GPUs. But it's not, it's not no huge difference. It's just a couple lines you need to include in your submit script. So there's a link in this slide in case you're interested in finding out more about that. So in addition to our traditional clusters, we also provide resource to Anvil, which is our cloud computing resource. Anvil uses the OpenStack framework and provides each user with a customizable virtual machine. So there's several different reasons why you might need access to a cloud resource rather than just a cluster. One could be if your application requires root access, or if you have an application that only runs on Windows, you can spin up a Windows virtual machine on Anvil for that. Or if you need persistent database server or something like that that you need to set up that's always running and that your jobs always have access to. So you can find out more information about Anvil and how to request access to it. It's free. We want you to tell us why you need it and make sure that that you do actually need it. So you have to sort of give just a brief justification for why you need access to Anvil. And then we will add you to the users who are allowed to create Anvil instances, and then you'll be able to just set up your virtual machine and use it. The documentation that we have is pretty detailed, so sometimes we do go over in our workshops how to do it, and we go through it together step by step. But it's very hard to do in a workshop setting, even in person. It's quite complicated. It's a little bit complicated the first time you set it up. Subsequent times when you use your instance, it's very easy. But just the first time you set it up, there's a lot of little steps. So it's not very easy to do in a workshop setting, but our documentation is very detailed. So we don't really present anything in our workshops anyways that's not already in our documentation. So if that's a great place to start if you need access to that. So the other resource that's listed on the slide is Attic. That's a storage resource. So if you need to back up your data somewhere, Attic's a great option. It's a nearline data archive, which means that it's not the files you put in there aren't directly accessible to the jobs that you would submit on our clusters, but it's fairly quick to use Globus to transfer them to the clusters so that your jobs do have access to them. So it's backed up in two different places, in Lincoln and Omaha, and there's high-speed connection to Attic, between Attic and our clusters when you're using Globus to connect to copy your files to and from Attic. We do charge for Attic usage, but it's subsidized and costs much less than commercial storage. Any questions so far? So we provide access, free access to the shared resources to all NU students, faculty, and staff. And then we do offer also dedicated resources. So that's where you would pay to lease priority access to a handful of nodes, for example, or for Attic storage space or something like that. So if you need more than what's provided for free, then please contact us and we can sort of show you the prices that we have on some of the on our dedicated resources. We also provide educational services through workshops such as this one. And we also provide classroom tutorials sometimes for particular classes or for groups who need something tailored to their group, some kind of educational or hands-on training for their group. We will also consult with you or your research group if you need one-on-one help. You can come to our office hours, or you can schedule something outside of those office hours if you need to. And then we are partners with other national computing resources such as Open Science Grid and Exceed. So if what we're offering isn't enough or isn't suited for what you need to do, then it's possible, contact us and it's possible that we can find a resource that is and put you in contact with them. These are just some headlines of various kinds of research that was done or made possible by Holland Computing Center. So, it really runs the gamut from, physics to biology to humanities even. What sorts of research can be done? Anything that involves computing, essentially. Okay, we're gonna switch gears and just talk about the logistics of how to connect to the clusters. So if you've already done this, there might be a few little bits of information in here that you didn't know about yet. So when you connect, like I said before, you're SSHing secure shell, that stands for secure shell. So you type SSH, you know, and your username and your at crane.unl.edu. So that's why we say SSHing. So you're connecting to the login node, and you'll open up a shell on the login node, and from there you'll be able to enter commands or submit jobs, or you know, manipulate your files that you have on the cluster. So how do we do that? You probably have already done this, but if you are a Mac user or Linux or Windows 10 user, you can open up a terminal. On Mac, it's called Terminal, and on Windows, it's called, I believe, I'm blanking. I think, is it Command Prompt, Colin?
It is.
Okay.
Or PowerShell also works with Windows 10.
Okay, thank you. Yeah, so you'll just open up a terminal, and you'll type SSH, your username at, and then the cluster that you want to connect to. So crane.unl.edu, for example. And then on Windows, you would, older versions of Windows, you would have to install something called PuTTY, which has kind of this graphical user interface window. And you'll enter the the name of the cluster. So right here, you'd put crane.unl.edu, and then you'd click open to connect. And then at that point, it will ask for your username and password. So since we use two-factor authentication, once you enter your password, it will ask you how you want to authenticate, and it'll give you a number of options. We recommend everyone use Duo Push, which is sends a notification to the Duo mobile app on your phone. And then you'll have to just click on that notification on the app, and then you'll be logged in. If you ever receive a notification that someone's trying to log into your account and it's not you, then of course don't click approve, click deny. So that's, otherwise, you know, the two-factor doesn't work. So if you, there are a couple other options. You can have it call you and give you a passcode, or send passcodes through SMS to your phone, and then you would use one of those passwords and enter it on that line. And then alternatively, if you're at a place where you don't have cell service for some reason, you can look at that Duo mobile app on your phone and click on this little key icon, and it will generate a passcode for you, and you would just enter that on the line. So there's several different options. Oh, and then, you know, if you do have a YubiKey, some people use a YubiKey, which is a little hardware token. You put that in the USB slot, and you just touch the little dot or whatever it is that's on your YubiKey, and it will generate this long passcode that will log you in. So, okay, anyone have questions about logging in? Hopefully everyone's already done that before, and we'll do it in just a minute. When we get to exercise, we'll log into Crane and run the exercises on Crane. So before I do that, I want to talk a little bit about file systems. So you may have heard us mention home or work, or, you know, attic, obviously I just talked about. So I want to talk about the different places that you can put files on Crane, and what the trade-offs are. So this diagram just shows the different storage locations in order of increasing ease of access and decreasing redundancy, so decreasing backups. So on the far left, we have, of course, attic. It's not as easy to access because it's only accessible through Globus, and the files there are not directly accessible to your jobs. Your jobs won't be able to see those. It is, but on the other hand, it is backed up in two different places. So you're not going to lose data that you put on attic. Home is backed up as well. And it is accessible to your jobs, but it's not as fast as work. If you put something in work, it's much faster for your jobs to IO to that directory. And your quota's fairly small. You have 20 gigabytes per user. Common is somewhere in between home and work. It's mounted on both clusters, unlike home and work, which are different on the two different clusters. Common is on both. So if you put a file in Common, you will be able to see that same file on Crane and Rhino. The quotas are a little bit bigger. Well, it's per group, so it's 30 terabytes per group. It's a lot bigger actually, depending on how big your group is. But it's much bigger, and you can pay for more if you would like. Common is not backed up though, so don't put valuable data on Common that you don't have backed up somewhere else. Work has the fastest access to your job. So if you have a job that does a lot of I/O, you'll want to put the input files and write the output files to Work. You don't have to pay for access to Work. And your group quota is 50 terabytes. It is not backed up, however, so you'll want to also make sure that you've backed up your files somewhere else. And it is also subject to our purge policy. So this is very important for you to know. Any files that you put on Work and you do not access in 6 months will be deleted. So just make sure that you back up those files somewhere else if they're important to you. Common and Home do not have a purge policy. And Attic, of course, also does not. It's just Work. And that's because Work tends to fill up really quickly, and then people fill up their quotas, and it slows down quite a bit when it's 90% full. Okay, so let's do an exercise together. So what I didn't mention yet is that there's a shortcut for your common directory, and it's $ all caps common. So if you type CD $ all caps common, you're going to go into your common directory. And likewise for Work and Home, it's the same thing. It's $ all caps Work and $ all caps Home. So the first exercise says to change, well, we're first going to log into Crane, and then we're going to change to our common directory, create a text file there called bio.txt, which contains our name and department, and then change to the working directory and download some files that we're going to be using later. So I'm going to share my terminal real quick. Okay, can everybody see my terminal? Let me know if you can't, or if it's too small for some reason. So I'm going to log in. I'm not logged in yet, so we can, if you haven't logged in yet, please do so. Okay, so I'm logged in. I'm going to clear my screen so that, well, actually, before I do that, let me show you. So when you first log in, it should show you your usage on Home, Work, and Common. So if it looks like you're starting to fill up those quotas, then you might want to think about moving things. This is a demo account, so there's almost nothing in there right now. It also shows my group's usage and then everyone's usage. So it looks like Work is 68% full, so it's starting to fill up a little bit. I'm going to clear the screen so everything's up at the top. Okay, so the first thing it asks us to do is to CD into Common. So first though, let's see where am I? So when I first log in, I'm just automatically in my home directory. So that should be the same for everybody, except your home directory is different than mine. Now let's CD into Common and see where that is. Oops. Now I'm going to enter PWD, and I'm now in, instead of Home demo 01, I'm in Common demo 01. So it should be Home or Common, and then your group name, and then your username. Okay, so the exercise asks us to create a file. We'll use Nano because that's what we were using the last 2 weeks during our Bash and Git lessons. And then we're supposed to put our name and our department. I do Control X to save that, and then Y for yes, and then enter. So if I do cat bio.text, we see those are the 2 lines we put in there. All right. And then if we want to, we can add something here. We can copy that to our home directory. Copy bio.text. Let's move it to our home directory. Actually, this will copy it, not move it. Now let's go back to the home directory. And we see bio.text is now there. And then here's the stuff we had from last week. Okay, so the next part of the exercise tells us to go to our work directory. So let's cd work. Oops. And then pwd. Now we're in work, and then your group name and your username. And let's clone the repository that has some of the examples that we're going to be using later. So it's git clone and then the URL. And you can probably just copy and paste that from the slide, but I will also put it in the chat here in case you want to copy and paste it from the chat. Okay, so I type ls now. I now see that there's a directory called job examples in my work directory. And generally speaking, you will want to submit jobs from your work directory. So that's why we moved them to there. Okay, so please, once you're finished with that and you've gotten to work, please put the green yes button by your name in the participants panel. So I know that we're ready to move on. If you have any problems with it or questions, put the no button there. All right, I don't see any no's, so I'm going to go ahead and move on. Okay, so when you're using work and common specifically, it's a good idea to avoid large numbers of files, especially in any one particular directory. Use subdirectories to partition your files of different types, or files that are used for different projects or for different jobs. And remember always that storage resources are finite. So, you know, if you don't need to keep something in there and you're done using it, then think about removing it. And then use Globus for file transfers, which we will go over soon, especially for large files. But if you have a preferred method of transferring files, then and it works, then by all means use that. And please back up your valuable data and output regularly. We have to keep the work directory running smoothly, so we can't let it fill up too full. But we don't want to see you guys lose important data. Okay, any questions so far? I'm going to switch gears and talk about transferring files next. All right, so as I've mentioned several times already, we recommend using Globus. There's the website that you'll use when you transfer files. So you'll go to that website, and it's essentially a portal where you can transfer your files to and from the clusters or to and from your laptop. And it's, you know, it's a very kind of user-friendly, pointy, clicky interface. If you have another SCP client that you prefer, some other examples are listed here, like WinSCP, CyberDuck, and FileZilla, then you can use those as well. You can also transfer things from the command line using SCP. I won't go into that today, but sometimes, for me anyway, it is faster just to type it directly into the command line. So I use it quite often, actually. So if you'd like to, you can use SCP. So why do we recommend using Globus Connect? Well, first of all, what it is a file transfer service. That's the URL again. By using Globus, you'll get fast and secure and robust transfers with a user-friendly web interface. It uses our high-speed transfer nodes by default, so it'll generally be faster. And you can transfer directly between the clusters and Attic and your personal machine. So this is just sort of a pictorial representation of that. But I think you guys get it. So the steps are fairly simple. You navigate to the website, you will log in, and you can use your UNL credentials. So you shouldn't have to create a username and password for Globus. And then you will select the endpoints. Globus used to call them endpoints, and now they call them collections. So they're kind of used interchangeably here in my slides. But you'll select the endpoints for your transfer. So that would just be like where you want to transfer from and where you want to transfer to. So one endpoint might be Crane and the other endpoint might be your laptop. If you are planning on using a laptop, which most likely you are, or your desktop or whatever it may be, you'll need to first install some software called Globus Connect Personal, and I will go over the steps for that in a minute. And then you'll need to authenticate the endpoint. So Globus needs to know that you are a valid, user of that endpoint, and so you need to authenticate using your HCC credentials, so that Globus knows which files you have access to on that resource or on that endpoint. And you'll need to authenticate every 7 days per endpoint or per collection. So if I used Globus within the last 7 days to transfer something from Crane to Rhino, I will not need to authenticate again until it's been 7 days. And then you just click on the Start Transfer button, and you can, if it's a particularly large transfer and you want to monitor its progress and see if there's any interruptions, you can monitor the status of that transfer, and there's some other tools there on the Globus Connect website that you can explore. And then there's some specific instructions for the steps I just talked about, including screenshots and things like that on our webpage. Okay, so let's go ahead and do it. I'm going to go through it together with you guys. If you'd like, you can watch or you can do it yourself as well. We're going to log into Globus, activate the HCC Crane and HCC Rhino endpoints, and then just try a job transfer. We're going to transfer the job examples directory that we just downloaded into our Crane work directory and put it in our Rhino work directory. So I'm going to share my browser window. Okay, so I've just gone to globus.org here, and I cleared my browser settings, so it's going to make me log in again, which normally it doesn't. Normally when I go here, I'm just automatically logged in. So this step you won't have to do every time. So you'll look up your organization. And then it takes you to the UNL TrueU authentication page here. And if for some reason you don't have, you aren't part of UNL or UNO or any of the other universities that have in common, you can create I believe you still can just create a Globus ID and log in that way. So you'd have a Globus ID and password, and that's how you would log in. Okay, but most of you probably do have a UNL login or UNO. Okay, so here I am. I'm on the file manager tab, and I need to search. I'm going to search for a collection. So I'm going to search for Crane. So here it is. It's actually called HCC # Crane. And it's telling me I need to authenticate. And that's because I cleared my authentication so I could show you guys how to do it. But you only have to, this is the part you only have to do every 7 days. So now I enter my HCC credentials. Okay, so it's your username, your HCC username, password, and Duo credentials. All right, now you can see that it shows me what's in my home directory on Crane. But the instructions were to transfer something from your work directory. So what you'll need to do is type in the path to your work directory. In the path field right there. Okay, now I found the folder that I want to transfer to Rhino. So I click on transfer or sync to, and then I enter the other endpoint that I want to use. So I'm going to search for Rhino, and I find HCC Rhino. And then I need to authenticate, of course, again, because I've only authenticated on Crane. And this is where I enter my HCC credentials. Okay, now it's going to show me what's in my home directory on Rhino. And that's actually, I want to transfer to my work directory on Rhino. So I'm going to type in again, work, demo 01. Okay, now it looks like I already did this. So that's why but pretend that was not there. Actually, I can delete it. You can delete files from, from Globus as well. I don't usually do that, so sometimes I forget how. I'm going to delete it. And it, of course, asks me to be sure. So I'm going to say, yes, I'm sure. Okay, so now I'm ready to copy. Now when I say transfer, this is a copy. So I'm copying job examples from my work directory on Crane to my work directory on Rhino. And I just click start to start the transfer. And then I can click up here on view details to see if it's something that takes a long time, you'll see an event log. You can see if there were any faults or anything like that. Looks like nothing's happening right now. It's probably already done. So if I go back here and refresh my work directory listing on Rhino, I should see it there. Yep, and it looks like it successfully transferred. I now see it in my Rhino work directory. Any questions about that? How do I move? So I have a question in the chat is asking, how do I move to work directory on Crane? It does give me not found. So you'll want to type your I'm assuming you're talking about this field right here. You'll want to type in your work directory. So it's not going to be demo 01. It's going to be work, and then your group name, and then your username. So if you're still having issues with that, maybe we can address it during one of the exercises where everybody is working independently for a minute, and we can go to a breakout room, and you can share your screen with us and let us know what's going on. All right, thanks, Mohammed. Okay, so let's see what's the next thing on our exercise. I think I think that's it for this exercise. So let's go ahead and move on to the next one. Any questions about that one though? Any other questions? Great. Okay, so next we are going to set up a Globus Connect personal endpoint on our computer, our personal computers, and make a transfer to or from our personal computers. So it says transfer the README file from Crane to your personal machine, and that's in the job examples directory. And then we'll transfer a file from the personal machine to your home directory on Crane. Okay. So I'm going to switch back to my browser for a second. All right. So I'm going to go to endpoints. Over here on the left-hand side, there's a tab that says endpoints. And then up on the top right, it says create a personal endpoint. And then download Globus Connect Personal for Mac. So these are just the steps for installing, the general steps for installing something on a Mac. For Windows, it might look different. I already have it on my Mac, so it's going to probably just replace the one that's there. It just takes a minute or two. And then you'll want to open it and run it. It has you log in. And then behind my window, it actually opened up a Globus Connect personal setup page. Can you guys see this window, or do I need to share it? I'm going to just share my whole desktop right now so you can see, make sure you can see this. Okay, so what it opened is this little window, and it wants me to give this desktop or this endpoint a name. And it says it was set up, so I exit, and then I can just go back, to where I had globus.org, the portal open. And then actually I'm going to go to my endpoints tab again and say click on the Administered by You tab, and my Emily's Laptop one should be in the list here. It's the one I just created. So if that didn't work for you for some reason, that might be something that we'll have to go over with you one-on-one in a breakout room during one of the exercise sessions. Can I see everybody who had issues with that or didn't work? Can you put a red no button by your name in the participants panel so I can get an idea of how many people had issues? Okay, so I see just one. So let's, actually it's a good time for, for a break. So I'd say let's take like a, I'm gonna go through I'm gonna finish the exercise and then we'll take a break after that. And then I'll use that time to help anybody who's having issues with it. So let's go ahead and complete the exercise. So I have this new endpoint called Emily's Laptop. So now I can go back to the file manager, and let's say I want to do a transfer from Crane to my laptop. I can enter, if I click on that field, I can either search for it just by typing it, and it will find it. Or I can go to the like recently used or something like that. Sometimes it's just listed there if you've used it recently. Okay, so now it puts me in my home directory, and I'll just transfer it. I'm going to open the desktop and just transfer it to my desktop. It says in the exercise to transfer the README file from here, from Crane. Let's find it. Okay, here it is. And I'm going to transfer it to my desktop. So I highlight readme.md and click start. Okay. So wait just a second. It should be pretty fast, and then I'm going to refresh this list and see if it worked. Try again. Okay, there it is, readme.md. All right, now we can also just transfer something. I think the exercise has us transfer something to our home directory. So I will just grab, I'll just grab that file again and transfer it to my home directory on Crane. And then if I refresh the listing of my home directory, might have to wait just a second. It should appear there when it's done transferring. There it is. Okay, great. Any questions about that, about using your Globus Connect Personal endpoint that you created? Did that work for everybody? Was everyone able to do that? How do people think it worked? Was it, do you think it was overly complicated, or it does get easier? So next, the next time you log in to Globus, you'll probably be logged in automatically, and you won't have to do that step, and the endpoints will be authenticated. And you don't have to authenticate on your Globus Connect Personal endpoint. But you do have to have Globus Connect Personal running in the background. So if it's not, it will give you a message and you'll have to just open it and run it. Okay, so there was a question in the chat, is Kaggle and Globus? I don't know what Kaggle is, I apologize. Maybe one of the other helpers does. Anybody? All right, if someone has an answer to that, they can enter it into the chat. Otherwise, I think we'll go ahead and take a 10-minute break, since it's a good time to break, and I can help help the one person who's having issues with Globus Connect Personal, and we will come back at 2:05. Okay, so any lingering questions? Everybody able to transfer between your laptop and Crane? Okay, if not, we're gonna go ahead and switch topics, and we're gonna talk about running jobs on the cluster. So once you've used Globus and transferred all your input files and executables and all that kind of stuff to the cluster, or anything that you need, you'll probably want to run some jobs. So all software runs and analyses have to be done on the worker nodes. So I did mention this briefly, but you can run really small test codes if you want, if they're really short and really not memory intensive on the login node. But ideally you would not do that. There are resource limits on the login node, so your job could be just killed if it runs too long or uses too much memory, or one of the sysadmins might see it and say, oh, that's not okay, they shouldn't be doing that, and they'll just kill it. So try not to do that too much, but you can definitely edit files and manage your directory tree and edit things and just stuff like that. And even compiling things is usually okay. And then once you're ready to actually run something, you should run it as a job on a worker node. And there's a couple different ways to do that. So you can run it in interactive mode, which means you open up a shell on a worker node, and then you just type your commands into the shell, and you see the output that it creates live. Or if you're all ready and you've got, your job's working and you've tested it, you can submit it in batch format. So you can, which means you create a submit script that contains all the requirements that your job needs. And then you submit it to the scheduler. The scheduler finds a resource that's available to run your job, and then it runs it on a worker node, creates output files, and puts them wherever you've specified for the output files to go. And then you can view them when the job's done. You can view output files. Some of the output it creates, you can look into that file while your job is running to see if it's creating output. So it's not that you have to wait completely till the end of your job's completion to look at those files, but some of the error and output that it creates won't really be ready until the job is completed. So you may have heard me mention the name Slurm before. That's just the name of our job scheduler. It's software that it stands for Simple Linux Utility for Resource Management, and is essentially a cluster management and job scheduling system that's used on most of the top 500 supercomputers. And so it's very commonly used. If you have access to another cluster somewhere, they probably use Slurm as well. And jobs are assigned based on the user priority and an algorithm called fair share. So that essentially means that the more you use the cluster and the more jobs you run, the lower your priority is going to be. And people who haven't used it as often recently or as much recently are going to have higher priority than you. And that's just to keep things fair. So as I mentioned, there's two different types of jobs. Interactive jobs are submitted using the srun command. So you type srun, you give it some options, some job requirements, and then then you type enter, and then you'll be allocated. Once a worker node is ready to run your job and there's a core available to run your job on, then your shell will switch to that worker node, and you can run things from there, and you'll interactively run your script or whatever it is, and you'll be able to see the output directly on the screen. Batch jobs, on the other hand, are submitted using an sbatch command, followed typically by just the name of your Slurm submit script, which is a text file that contains all the requirements for your job and what you want your job to do. And we'll go over some example submit scripts soon. Okay, so typically how people run things is in batch jobs. So you don't have to sit there and monitor your jobs the whole time. If you've tested your jobs, you know they work, and you just want to send them off and have them run somewhere without you having to do anything and without you having to be logged in. So first, as I mentioned, you'll need to make a submit script, which includes all the job resource information and necessary commands. And if you request a certain amount of memory or runtime and you go over those amounts, then your job will be killed. So you want to make sure that you've requested enough for your jobs and give it a little bit of a buffer just in case it goes over a little bit. But you don't want to request too much, because if you just request the maximum amount every time, then your job will just take a really long time to even start running. It will sit there in the queue for a long time waiting for a resource to become available. And it will also decrease your priority. So just request what you need with a little buffer of extra memory, for example, and runtime. So once you've submitted your submit script using the sbatch command, it goes into the job queue and it sits there and waits for a resource to become available. And you can look at what's in the queue by typing SQ, SQUEUE, to see what's there and to see the status of the jobs that you have in the queue. Once your jobs have finished, either they've completed successfully, or they've failed, or you've removed them manually from the queue, they won't be in the queue anymore. So you won't see them when you type SQ on the command line. And then if you want to look, sometimes this can be helpful to see previous jobs that completed or failed. You can use the saccount command with including options, right? Saccount will just show you a bunch of information that you don't care about. So you'll want to include some very specific options after this to see previous jobs that you ran. So we'll go into details about that soon. All right, so here is a sample submit script. This is just a file called serial.slurm. So this is what it would look like if you're on the terminal and you type cat serial.slurm, and then it would print out the output from, it would print out whatever is in the file serial.slurm. So the first line there is the shebang. That just tells the scheduler what interpreter to use to interpret this file. The next lines, they look like comments because they start with the pound sign, but they're actually sbatch directives. So in this case, they are not interpreted as comments. They're interpreted as requirements for your job. So every directive begins with the pound sign and the sbatch all in caps. And then you specify what you need. So for example, this job requires one node and one core, which is specified with the n tasks per node. It is requesting 10 minutes. That's in hours, minutes, and seconds. So that one is requesting 10 minutes. And the maximum amount of time you can run is 7 days on Crane or Rhino. So don't request more than that, or it won't, it'll give you an error. And it's requesting 10 gigabytes per CPU. Or you can just say --mem equals. If you want to specify per CPU, you can do it this way, or just total amount of mem, you can just do --mem equals. And I'll have a list of these on in a table on another slide too. You can give your job a name. So this one is called invert rand. This is just a name that you've specified so that when you type SQUEUE, SQ, to list all of your jobs that you have in the queue, you'll know that this is the one called invert rand. Each job is assigned its own job ID. And so that will be replaced here wherever there's the %J. So the error file for this job is going to be called serial dot, and then the job ID dot air. And likewise for the output file, it'll be called serial.jobid.out. And then after the Slurm directives is just whatever commands you want your job to run. So if you want to use MATLAB, you'll first need to load the MATLAB module. And we're going to be talking about software and modules and how to use them next week. So I won't really go into this much. But to use a specific software that we have installed, you'll load the module for that software first. So this job loads the module. It creates a directory in the Scratch directory temp to store information about the the job and the tasks in the job. This is just kind of a MATLAB specific thing that you probably don't need to worry about unless you do a lot of MATLAB. You run a lot of parallel MATLAB codes. And then finally, it just calls the MATLAB script invert rand using the 10 to the 4 as the input argument. And it runs it in a no display mode and then quits after it runs. So that's what this job does. It runs this MATLAB file called invert rand, and it uses as its input argument 10 to the 4. So this one's just a pretty simple job, but most of them don't have to get too much more complicated than this. So these are some of the more common batch options, some of which you saw in the previous slide. You want to specify the number of nodes that you need, but if you don't, you'll get one, all the cores you request will be on a single node. You want to request a specific amount of time. By default, you'll get only 1 hour. So if your job runs any more than that, you'll definitely want to include this one. The total amount of memory that you need. The units are in megabytes by default, but you can use other units after the number if you'd like. And then the number of tasks per node. So that's equivalent to the number of cores that you request. And by default, you just get 1. You could also alternatively request mem per CPU instead of total amount of mem. And that will just give you that much memory per task that you request. And then finally, you'll want to specify error and output and job name if you want anything other than the default, which is slurm-jobid.out and slurm-jobid.err. I think this is this is a mistake here. This should probably be .err. All right. So you can also use a number of different environment variables in the command section of your submit file. So that's that section where you actually run your codes below the Slurm directives. You cannot use them up above in the Slurm directives though. So occasionally you might need your job to know the number of tasks per node, or the job ID or the job name or the nodes it's running on, or something like that. So occasionally you might need to use one of these, and we'll do an example later that does, so you'll see what I mean. It's probably not super common that you'll need to use this, but it might come in handy, especially if you're submitting a job array. An array is submitting a whole bunch of jobs that all do the same thing. So you might want your jobs to differ slightly. If you submitted an array of 100 jobs, each job might need a slightly different set of input arguments, and you can specify that using one that's actually not listed here, Slurm array task ID. So we'll go over that example later. But yeah, you might want to use something about Slurm as an environment variable in your job. You can also use replacement symbols in your submit script, and there was an example a few slides ago. So the %j is that job ID. So there's some other ones you can use that sometimes come in handy, but typically it's mostly the %j for the job ID. But you might need to know the the index of the job array if you're submitting a job array or something like that. And these can be used, like I said, up in the SLIM directives, but not down below in the command section of your submit script. Okay, so how do I decide how many nodes, memory, time, etc. I should use for my jobs? The short answer is we don't know. And then the long answer is it really obviously depends on the application you're using, the input file sizes, the parameters you select, the resources you're using. So it just can vary. So you'll want to start with something, you'll want to guess. You maybe want to guess based on the memory and time that it ran on your laptop, if you tried on your laptop first. And use that as your starting point. Or maybe you want to submit a sample job and request a little bit more than you think you'll need. And then you can look at how much resources that job used and maybe extrapolate a little bit if you're going to use a larger input data set or something like that to guess how much time and memory your jobs will take. You might not know also what's the ideal number of cores to run on. Let's say you're using an application that can sort of multi-thread or use more than one core and split its time in half. So there's usually some peak number of cores after which the performance degrades, or not degrades, but it doesn't get a lot better if you double the number of cores. So you can do some testing to figure out what that peak is. So it's really just a trial and error process. These are some additional SBatch options that aren't as commonly used, but sometimes it's good to know that they're around. I'll just go over the ones I think maybe are the most useful. The -- test only. If you include that, it will just validate your script, make sure there's no major errors in it, and then return an estimate of when your job would start based on the current state of the queue and the requirements that you have in your submit script, but it won't actually submit the job. So that's kind of good to get an idea of, well, if I submit it requesting, 8 cores, will it start sooner than if I, request 16 cores or something like that? You can see how much time it will, is estimated that it will sit in the queue before starting. And then you can also have it email you when it ends or if it fails. So you can use mail type equals, and then you can have email when it begins, when it ends, if it fails, if it reaches the time limit, or there's a lot of different reasons you can have it email you. You can have it only begin after a certain time, or you can have it removed from the queue if it can't finish by a certain time based on the time limit that you have specified. So, and if you're, whoops, what did I do? So if you don't know, here we are. So if you don't know what's possible, or you can't remember one of these, you can definitely, I do this a lot. You can just Google Slurm SBatch and you'll find the manual page that has all of these and more. Okay, so what happens? So you submit a job, which we'll do in a minute, I promise. I'm sorry about all these slides. So you'll submit a job, and then you'll want to monitor that job. So you'll use the SQ command. The output of that is going to be just columns of data. So the first column's the job ID of each of the jobs, the partition it's running on, the name of the job. So that's the job name you give it when you in your submit script. The user, so it's your username, the state of the job. So you'll mostly just see pending and running jobs, because once it's failed, canceled, or completed, it will leave the queue pretty quickly. So you mostly won't see those in there, but just occasionally. Time will be the length of time the job's been running. Nodes is the number of nodes it's running on. And then the last column is either a node list. If it's running, it will be a list of nodes it's running on. And if it's not running, it will give you a reason. So this reason is reservation, which means it's just waiting for a reservation to open to run. Here's some of the more common reason codes, although there's a lot more than this. Dependency would mean it's waiting for another job to finish that you specified this job depended on. So you can include dependencies in your job submissions, and that means, I don't want this job to start until the previous job has finished. So this reason code means it's waiting for a job that depends on to finish. Node down means that a node that's required by this job is down. If you see this, then you probably would want to contact us. Or check your job, first check your submit script and make sure you haven't requested anything strange. Priority is very common. It just means that you're waiting for your job to run because other jobs have a higher priority than yours. That's just part of that fair share that I mentioned. Required node not available. That means you've requested something that either doesn't exist or it's not available at this time. So you'll probably want to contact us if you see that as well. Reservation is common to see. It means you're waiting for a reservation to become available. And resources is similar. You're just waiting for the available resources to become available, but in principle, they do exist. So you want to just go to the terminal and type SQ and then enter, because you'll see a list of all of the jobs in the queue, including your own and everybody else's. So that's not probably that interesting to you. You'll want to almost always do SQ-U and then your username. But if you want to look at a specific job, you could do -J job ID or list of job IDs, or look at on a specific partition, or look at jobs only jobs that are pending or only jobs that are running. So there's some different options here. This one's kind of might be helpful too. This will give you an estimated, if the job is already scheduled to start, it will give you an estimated start time. If it's not scheduled to start yet, it's still waiting for resources, then it won't. Okay, so let's say you submitted a job and you notice that there's some problem with your submit script and you want to cancel it, or it's not doing what it's supposed to do, so you want to cancel it and try again, or fix something, try again. So it's just scancel followed by the job ID of the job. Alternatively, you can cancel all the jobs with a specific name, or all of the jobs in a specific partition, or all of your own jobs, or all of the jobs in a specific state. You can't accidentally, as a normal user, you can't accidentally cancel someone else's job, so you don't have to worry about that. But you might want to cancel all of your own jobs. I mentioned job arrays. So if you want to submit a whole bunch of jobs at once that do something identical, you can, and that's using sbatch -- array equals. And then you would put like 1-10 would start an array of 10 jobs. And all the jobs would do the same thing, whatever you put down in the command portion of your Slurm submit script. But you can make them all do slightly different things by using an environment variable that would make each one, for example, use a different input file, or use a different argument for the script that it runs. I also mentioned dependencies. So if you want to submit a job, but you don't want it to be submitted until another job finishes, you would submit it with this option. So it'd be dependency equals, and then you would put, if you wanted it to wait until the previous job finished without error, you'd say after OK, and then the job ID of that job. Or if you wanted it to start after the job failed, you'd say after not okay, and then the job ID. So maybe you wanted to check why it failed or something like that. All right, so let's finally do an exercise. We're going to navigate to the MATLAB directory that is inside of the job examples directory that's in our work directory on Crane, okay? So then we're going to locate serial.slurm file, look at the contents, answer a few questions about the requirements of the job, and then submit the job and check the output. Okay, so let's go ahead and do that. I'm gonna switch to a new share. Okay, so here's my terminal again. I'm gonna clear the page. Okay, I'm in my work directory on Crane. That's where we should all be. Okay, if anybody is having problems getting to their work directory on Crane, please let us know. Put the red no by your name so we can help you. But if you're not sure how to, if you're logged in but not sure how to get there, you can go CD $ all caps work, and that should put you there. Okay, so if I type ls, I should see the job examples directory that we downloaded earlier. And let's go ahead and CD job examples. You can use tab completion to complete that. If you just type the J, it'll probably complete it. And then ls. All right, we want to go into the MATLAB directory. So MATLAB ls. Okay, let's take a look at serial.slurm. I'm just going to use nano. Or you can use, actually, let's use cat. I'll just print it to the screen. Okay, so this is the content of that file. So it's requesting one node, one core, 10 minutes, 10 gigabytes. The job name is invert.rand. And the error and output files are serial.jobid.error and serial.jobid.out. It loads a MATLAB module and then creates that temporary Scratch directory using the Slurm job ID. So that's one of those environment variables. And then it runs the MATLAB script using an input argument of 10 to the 4. So if you're, does that kind of make sense to everybody, what it's doing and what resources it's requesting? We can go ahead and submit the job, sbatch, and then the name of that file, serial.slurm. Okay, so it says it's submitted. I'm going to check on it by typing sq-u and then my username. Okay, so when I do that, I see the job ID, the partition it's on, the name, or at least a shortened version of the name, my user ID, the fact that it's running, it was running for 6 seconds on one node, and here's the node list. That's the name of the node it's running on. So if you got that to run, can you guys, we can go ahead and post the job ID in the chat, and then we can all kind of check that you guys are running this correctly. I'll put mine in the chat. Thank you. Yeah, so we can like check on that one. Let's do this, sq-u-e j, and then this is the job ID that's just posted. So it's also running. Oops, that was mine, sorry. I meant to grab. I grabbed the wrong one. Let's try that again. Right, so this is somebody else's job. So you can see everyone else's jobs in here. So this information is not really private. It's just, it's visible to you, but you can't mess up or change anybody's jobs. Try another one. Oops, that was the same one. I'm having problems copying and pasting from the chat, as you can see. Oh, that one must have finished because it's not in the queue anymore. So if I do squ my username again, okay, mine's still running. But if you see nothing there, then your job's probably finished. I don't think mine is the same as yours, Veronica. It must have been a, if you want to give me your username, we can just check by your username. So that's the job ID, which is different than mine. Mine was this up here. So you must have just copied and pasted wrong, maybe. Okay, let's see if mine's finished yet. Okay, looks like mine's finished. So let's take a look. We have some output file, an error and output file here. So let's take a look at the output file. Okay, so the answer is how much time it took to execute this. So that's going to be, it's just executing on one worker node, or on one core, using a MATLAB parallel pool of one worker, and it takes 106 seconds. So we're going to try next running on more cores and see how long it takes for that. So the next part of the exercise asks us to create a new submit script that uses 4 cores and then submit it and see if it ran faster. So I'm going to just copy Cheryl.slurm to serial 4.slurm. So this is going to use 4 cores. It's not really serial, but we'll pretend it is. Now I'm going to edit it with Nano and just change the number of n tasks per node to 4. And MATLAB, this inverting function is able to utilize all 4 cores. Okay. So it says submit the job again and compare it to the initial run. So let's do it. sbatch serial 4.slurm. Okay, so there's a question. Could you please explain what are the list of files in the MATLAB folder and how does serial.slurm recognize the MATLAB program and data input? Okay, so if I type ls, here's a list of files. This is the list of files that's in your directory. The MATLAB script is invertrand.m. You can look at that if you'd like. You can see what this MATLAB script actually does. It generates a random matrix and then it inverts it. You don't need to worry about how it does it. This is not a MATLAB programming course, so you don't need to worry about it too much unless you're really curious. You can look this over later. But it inverts the matrix and then shows how long it took to invert the matrix. So your submit script, serial.slurm, right? It loads a MATLAB module. And what that does, we'll talk about it next week, but it just sets up your environment so that it knows where the MATLAB executable is located. It knows where to find MATLAB, the program. And then you don't need to worry too much about this unless you do a lot of MATLAB parallel programming, but it's a good idea to create this temporary directory to store information about the job task. And a good idea is to name it with the Slurm job ID so that each job has its own, even if it's on the same node, it has its own space to store this information. And then you'll want to just invoke MATLAB in the no display mode because you don't want the graphical user interface to open up. And then oh gosh, I forget what -R is, I apologize. I think it just means run this script. So you'll put the name of the script within its input arguments and then comma quit, because that's what you want it to do next in quotes. So that's generally how you run a MATLAB program from the command line. Right, so you put all of your command line options here, everything you want your job to actually do, everything that you would run if you wanted to submit, or if you wanted to run this invert rand MATLAB program just from the command line without opening up the graphical user interface of MATLAB. Does that make sense? Okay, let's look at let's check the queue. Okay, my job's finished. Let's take a look at the output. Okay, the output is, I didn't delete the previous output, so it's still there. So the output of the new job is here. It's just the job IDs increment. So it's just the job ID that's the largest one is the most recent one that I submitted. So let's look at that file. All right, so this time instead of, what did it take before? 100 seconds? I don't remember. Something like that. Yeah, 106 seconds, it took 15 seconds. So it was quite a bit faster, actually. Okay, everybody see something similar in their results? Everybody's faster? Hopefully not slower. Yeah, I'd be curious to see if other people ran this on 4 cores, whose was the fastest. So post them if you like. Oh, looks like mine was the fastest so far. Okay, so the next part of the same exercise just asks us to submit the job again and get a list of the queued jobs and then try canceling one of them. So let's just do that. I'm going to submit the slower one. And I can even submit it twice. In fact, I'll do both of them. I'll submit serial.slurm and then serial4.slurm. Okay, and it looks like I now have 2 jobs in the queue because I just submitted 2. I'm going to grab this job ID. Actually, I want to cancel the most recent one. So I'm going to grab the most recent job that I submitted and cancel it. And now I only have one job. I could also do S cancel -u and then cancel all of my jobs. And then that will cancel all of them. Okay, does SQ and S cancel make sense to everybody, how that works? I mean, that's how you'll use it most of the time. You might want to get into the more advanced options that come with those functions, but that's typically probably how you'll be using it. It's just canceling a particular job or listing your jobs and seeing what's running and why. If it's not running, why. We're gonna do one more batch job at the very end, but first we're gonna switch gears a little bit and talk about interactive jobs. So, so far we've been submitting batch jobs, and that means that the output of the jobs is going into a file that we can view from the login node, but we can't view it as it's being created or as it's being output to the terminal, the standard output on the terminal. So if we want to do that, then you would submit an interactive job using the srun command. So as I mentioned before, what happens here is that you request whatever you need for your job. So you can still request the number of nodes, the amount of memory, etc., whatever the runtime, if you want more than the 1 hour default. And then at the end, you do --pty and bash to tell it what kind of job you want. So that will open up a bash shell on a worker node. And then you might have to wait. It'll just say that it's queued and it's waiting for resources. And depending on how much resource you requested, you might have to wait for a while. But for this simple job, you probably don't have to sit there very long at all. Once you're allocated resources, it will tell you that, and then your prompt will change. Instead of seeing login.crane, you'll see the node name of the node you're on, and then the typical prompt at the end. Let's see. You'll be kicked off once your time is up. So just make sure you requested enough time, and then you'll lose anything that's stored in memory at that point. So if you want to keep anything, you'll have to put it into an output file. Just a second, there's a question here. So someone else, it feels like you don't want to write output files to a worker node. If you want to write a file, how do you point it to your own directory? So, yeah, so when you're on the worker node, you're still writing files into your work directory. So, yeah, so if you just write a file, it'll end up in whatever your current directory is in. The /temp directory was something slightly different. So that's some scratch space that you can use, and anything that you put into that directory will be deleted when the job finishes. But just typical output files will just be put into whatever your current working directory is. And that's typically your work directory. It's where you submitted the job from. If your job CDs into another directory first and puts the files there, then that's where they'll be. I don't have a link for the command history today because I wasn't planning on doing quite as many commands today. So I apologize, I don't have that. But if you need to see something again, let me know. All right, so back to interactive jobs. So let's go ahead. That's the typical, syntax. So it's srun, your batch options, --pty, and bash. And then you'll be allocated a resource, you'll run your scripts, and then when you're all done and you want to exit from that, you type exit. So let's go ahead and try it. The next exercise says, oops, I'm sorry, I forgot to share my slide with you. Hopefully I'll have the slides open anyway. Okay, so this is the slide on interactive jobs. So this is the general command. So it's srun, your batch options, and then --pty bash. This is what it looks like. It'll tell you it's queued and waiting for resources. Then when it's allocated, it will tell you that, and your prompt will change to the name of the worker node that you're on instead of the login node. All right, so exercises. Request an interactive job requesting 1 node, 2 tasks per node, 2 GB of RAM, and 2 hours of runtime. Okay, let's go ahead and I'm going to switch my share back to my terminal again. All right, I'll type clear. So as you can see, I'm on the login node. So the exercise says 1 node, 2 tasks, 2 GB, and 2 hours. Okay, nodes equals 1, and tasks per node equals 2. Mem equals 2 GB. Time equals 2 hours. And like I said, max is 7 days or 168 hours. If you need like 3 days and 2 hours, it would be, the days would go first with a dash, or just you could do 168 hours like that. Okay, so 2 hours, and then --pty bash. Let's get that all in one line here. Okay, now we're waiting. We really don't need more than 1 core for this, so we can switch it to, and task per node equals 1, and memory equals 1 GB, because we're not actually using all the resources we're requesting here. Okay, so it's allocated. So now the next part of the exercise says, go to the Python directory in the job examples directory, and then run a program called helloworld.py. So I'm gonna CD here, back up 1, and do ls. I see the Python directory there, and I'm gonna go there. CD Python, ls. Okay, so here's here's a submit script, which I'm not going to use right now because I'm running interactive jobs, so I can just run the Python script directly right here on the worker node. I'm on worker node C1106. That's, you probably don't really need to know that, but just helps to know that you're on a worker node and not the login node. So I'm going to type Python hello world.py, right? And it looks like it's not doing anything. And that's because what this script actually does is it sleeps for 60 seconds before it outputs anything to the screen. And it does that like 4 times. And then it finally says hello world and it finishes. So if you want, we can do is type Control-C to cancel it. And then we can edit that file and just take out that sleep command. Okay, so I'm going to just comment this out because, oops. Okay, let's try it again. Okay, so now instead of, it's supposed to sleep 60 seconds between each of these lines, and then it says how many minutes have elapsed. But I took that out because I'm impatient. And I just ran this on a worker node. So that's how you would kind of test your codes. Any questions there? So typically you'll learn during next week's workshop about using software, including how to load the module for Python, for example. There are some modules that are just loaded automatically for you when you log in. And so that's why I didn't load a Python module first. But typically first, if you're using software like Python, you'd want to load the module first or create your Python environment and then run that environment before you actually submit your script. But this is a very simple script that doesn't need any special packages, so I didn't do that. Okay, when you're done, you can type exit to get out. And now I'm back on the login node. Okay, how are we all doing? Any questions on that? So as promised, here's a bonus exercise that's just a little bit more. Let me share my screen again, just a sec. Share my slides. The next exercise is a bonus exercise for submitting job arrays. And I like job arrays. I use them whenever I can. So I wanted to include this because it might be helpful if you have a whole bunch of jobs that you need to run that are all very similar. So what this exercise has you do is create your own Python script, and it's just a few lines. So you can hopefully just copy and paste this here. I can copy and paste it into the chat, in fact. So you'll just open up a new file. Did that work? Okay, so it's copied and pasted into the chat. You'll just open a new file and put that in there. What this does is that it accepts an argument, and that argument is assigned to the variable sleep time. And it's whatever argument you provided this script when you called it from the command line. And it's the number of seconds that this script is going to sleep. And then it's going to output, I slept for sleep time seconds. And then you're going to submit an array of these jobs, 10 of these jobs, and each one is going to sleep for a different number of seconds. And the number of seconds it sleeps is provided by the Slurm array task ID variable. So that for an array, I specify that I want my array to go from 1 to 10. So the Slurm array task ID is going to be 1 for the first job and 2 for the second job, and so on for all 10 jobs in the array. So each one's going to sleep a different number of jobs. And here is where, this is your submit script here. And so here is where I provide that environment variable to the Python script as an argument directly on the command line there. Okay, so that's kind of how it works. Let's, where am I here? I'm in the MATLAB directory. I'm in a CD. I mean, we can do this anywhere, but let's go up and let's put it in the Python directory. That makes more sense. So let's create a new file called sleepytime.py. And then I'm going to copy paste this text into there. I hope this works. I only tested it once. And save it. Okay, now let's create a submit script. I'm going to call it python_array.submit. I'm sorry, I'm not sharing my screen with you. I just realized. Hold on, I'll go back. Okay, I'm sharing everything now. So I will do that again. I'm in the Python directory. So cd to your work job examples Python. And I created a new file called sleepytime.python, and I just copy and pasted that text into here. That's my Python script. And that should be in the chat, so you should be able to copy that from the chat. Okay, now I'm gonna create my submit script. So nano python array.submit. And I'm gonna copy and paste this. I will send it to you in the chat. And I'll copy and paste it here. So this job creates a job array of 10 jobs from 1 to 10. And you can make this something else. You can make it any sub numbers you want, really. I think you can even put in numbers that are not consecutive with commas between them. But usually it makes sense to do consecutive numbers. Nodes equals, so one node, one task per node, 1 gigabyte of RAM, and 10 minutes per job. And then each job is going to be, the output and error file is going to be labeled by the main job ID, if you will, and then dot, and then the Slurm array task ID will essentially go here. So it'll be like .1 or .2 or .3 or whatever, depending on which job it is in the array. Okay. Okay, so then we'll go ahead and submit it, see if it works. Actually, okay. Python array.submit. Oops, I have a typo. Sorry about that. Oh, let me fix it. I'm not sure why this is giving me an error. It might be just the line formatting because I copied and pasted it. I'm just gonna type it again. Okay. All right, and I look at the queue, I have, it says the job ID. It gives me this array range of Slurm array task IDs here for every job in my array. Let's type ls and see if we have any output yet. So I can also do this. Oops, sorry. If I do -I for, it will show me the queue and update it every 4 seconds. If I'm impatient, I want to watch what my jobs are doing, I can just have it output this, the SQ command every 4 seconds, so I can keep an eye on it. To get out of that, do Control-C for cancel. Another way to do it is watch, just watch and then SQ. And that will just update this every, I think it's like every 5 seconds by default, something like that. Oh, it says every 2 seconds, sorry. So it's still working on jobs 5 through 10, it looks like. Now 5 and 6 are running, but 7 through 10 are pending. Okay, let's go ahead and take a look at output. Okay, so let's see if let's just look at one that finished. So if I just look at the output from one of the jobs in my array, oops, cat, and then the file name. So it says I slept for 1 second. So let's try another one. It says I slept for 2 seconds. So, right, every one of the jobs in here did something slightly different, and we used that Slurm task ID to create that difference. So another way you could do it is maybe maybe each job uses a different line from a file as its input arguments, or something like that. So it grabs that line out of a file and uses that for its set of input arguments that uses for the Python script or whatever kind of script that you're using. So there's a lot of different ways you can use that environment variable in your job arrays. Any questions about that? I apologize because it's been hard to watch the chat while I'm presenting. So I hope that I didn't miss any major questions and that the helpers were able to address any that I skipped or didn't see. So I think it's probably a great time for a break out. I have 2 more slides and then we'll do a break and we'll switch gears and talk about Open on Demand. But I did want to mention a few tips before finishing. So let me switch my share just to my slides because I won't be doing any more exercises. Okay, so as I probably did kind of allude to earlier, it's a really good idea to test and develop your workflow on a smaller set of data or on a smaller number of jobs before you submit a large analysis or a very long job or a very large number of jobs. And one way to do this is to run an interactive job first, or to just run a small batch job. If a job's failing for some reason, or you're not sure if it's failing, or you don't think it's doing what it's supposed to do, before you email us, it's a good idea to just check the output file. So look at those .error and .out file and any other output files that your job is supposed to create when it runs. And then you can also use this other command called saccount to look at your previous jobs that are no longer in the queue. They already finished or completed or failed or were canceled. Let's go ahead. Actually, I think it's a good idea to just demonstrate that once. So I'm going to switch back to I apologize for all the switching, but I'm going to switch back to my terminal again. So I'm going to just grab one of these job IDs. And run saccount. And then you kind of format the output. Let's say I only want to look at the memory I requested. Oh, what are the other ones? Max RSS, so that's the max amount of memory that was used. The time that it ran and the elapsed time. Right, so it'll show you, this is for all of the jobs in that array. Each one has like a main job and then a like a controlling job and then a another job, I guess. So there's 2 listed for each one. So it lists so it didn't use very much memory, as you can see. Time is actually the time limit, and then the elapsed amount of time that actually took. So this is what I requested. This is what it used. Not enough to even register the time limit and the elapsed amount of time. And you can also use the job history command. It will summarize that as well, and it shows it for all of the jobs in that array. Requested CPUs, requested time, requested memory, how long it waited, and how long it ran, and the amount of memory that was used. So there's some good, and if you go to the link in this slide, there's some good other tips for checking on your jobs, monitoring them, troubleshooting, and seeing what went wrong. So what do you do if you're stuck? obviously read the documentation, our documentation, as well as the documentation for whatever application you're using. You can even, many applications have a helpful message that's displayed when you type -- help after the name of the application. Or you can use man for a lot of the, especially for the, a lot of the bash commands. So man ls, for example, something like that. Definitely consult Google. That's often one of the first things I do when someone sends a question and that I haven't seen before. I'll look through the documentation, I'll look through Google, and I'll try to find the solution for you guys. But you can do a lot of that on your own, and sometimes faster than we can because we have a lot of people to answer questions for. We have currently we have still remote office hours that are 2 to 3 on Tuesdays and Thursdays. So you can drop by there, or if those times don't work for you, you can schedule a different time with us if you have something that's just you can't resolve on your own, and or that you can't resolve through a ticket. Oftentimes when you meet with us, sometimes it's easier for us to be able to review your problem first ahead of meeting with you. So it's probably best to start with it emailing us and letting us know what the issue is. What's the submit script you're using? What's the job ID that failed for you? And give us as much information as you can. And we'll try to troubleshoot it for you. Okay, that's all I have for our HCC intro material. So I think we should take another break. Let's do a 15-minute break before we return at, let's go ahead and return it just at 3:30 to make it a nice even break. Is that okay with everybody? When we come back, Mohammed will be teaching us about Open on Demand, which is a whole different way to access the cluster and submit jobs.
Okay, hello everyone. Can you hear me?
Yep. Hi, Mohammed.
Hello.
Yes.
Okay, sounds good. Let me just grab in the chat. Okay. So hello everyone, and thank you, Emily, for the great previous session. It was really great, and I hope you guys enjoyed it. And the next part of today's session, I will talk about Open on Demand. So Open on Demand, it's kind of something like different than what we taught before. And we are going to talk about something like Open Demand, talking about like a virtual environment, or let's say like a GUI, which is a graphical user interface environment that you can help and you can work with the clusters, and it's going to help you. For example, if you are not familiar with the command line, this is another way you can work with the cluster using a graphical user interface. And so HCC resources, which is our resources, can be accessed through the Open on Demand web portal. And this will allow you and allow all the researchers or users on the HCC to manage their files and maybe create their files or directories, submit and monitor their jobs, access the shell as well, and spawn Jupyter notebooks or like RStudio, and interact with the virtual desktop environment as well, using graphical user interface environment. All of those can be done through a browser. So you don't need to install anything, and you don't need to, download or whatever. You just need to go to the a URL that we will provide you, and then, you know, put your credentials and you are ready to go and use Open on Demand. So today, our objectives. So what we're gonna talk about is we're gonna talk about introduction about Open on Demand. So I put links, each link, this is like some descriptions for our materials for each one. So first of all, we're gonna talk about introduction to Open on Demand. So then we're gonna go to the how to connect to the Open on Demand. Then we're gonna talk about chill access with Open on Demand. And then after that, we're gonna talk about managing and transferring files. Then how to create job, manage your jobs, submit your jobs, and then monitor your running jobs on the clusters. Then we will talk about virtual desktop and Jupyter Notebook, RStudio, and how to work with them using Open on Demand. So Open on Demand, as I said, is like a web portal that will help you to you know, access the clusters and work with the clusters, you know, using graphical user interface. And Open on Demand actually was developed by the Ohio Supercomputing Center, and was supported by and funded by the National Science Foundation. So what's the goal of Open on Demand is to provide a graphical user interface for the HPC resources. So for the people or users who would like to work with command line, who wants to, you know, work with the graphical interface, more familiar with the graphical interface than, you know, command line, this is the best way, I mean, to deal with and to use the HCC resources or any like supercomputing resources. So why Open on Demand is useful? So why do we need Open on Demand? First of all, it will give you an access to the HPC resources. As you know, your terminal, this is another way. So it will give us an access to our HPC resources. Also, it can also provide a file access to your files. You can view, edit, delete, or download or upload files using graphical user interface as well. So it can also include a job control to your jobs. You can submit your jobs, you can monitor your jobs, delete your jobs, whatever, and see the status as well for your jobs. On the other hand, also, it will like give you a terminal access. If you need a terminal, so you don't need to go to your terminal, or, you know, if you are using, for example, a Windows operating system, you don't need to go to, you know, your terminal and, you know, like access HCC resources again. So directly you can, you know, open a terminal using Open on Demand. Also, it will give you like an application access. So our applications is limited. You can't use everything in Open on Demand. So we provide some special applications you can use. One of the applications, Jupyter Notebook. The other one is RStudio. Also, it can help you also provide like a desktop, like you can, you know, have your like, you know, operating system that is installed in graphical user interface. You can work on it as like any graphical user interface operating system. And this will help you actually to, you know, view some of the files that, for example, like a graphical files or results that you need to show. And on the other hand, sometimes there is like some graphical user interface applications that will help you actually to access and work with. And also, like, as I said, it's a zero install. So you need just your browser and that's it. If you have your browser, you can access the Open on Demand. And it's easy to use for like most of the beginners. So like you didn't need to, deal with the command line interface a lot. It's just like, as most of the beginner users, they use like, for example, Windows or, Mac OS operating systems. So they are familiar with the graphical user interface more than command line interface. So it's the best way to help them, to get familiar and work with the HCC resources. So first of all, let's go and connect to the HCC resources. How we can connect to the Open on Demand. So like we have two links actually. We have two clusters, two mini clusters that most of the users they work with, which is a Crane and Rhino. So each cluster they have a link. So for example, if I want to connect to Crane, so I will go just to crane-ood.unl.edu. If I want to connect to Rhino cluster, I need to go like to rhino-ood.unl.edu. So you are fine to use any of them, but today like I'm gonna access just Crane. But what works for Crane will work for Rhino as well. So I will put those links actually in the chat box. So you can try to access any of them. So now I will flip to here. If I go like here, https crane-ood.unl.edu. So I will see this, portal that requires your credential to log in to the Open on Demand. So this is for Crane. So can you see my screen right now? Can you see the portal that's accessing, like asking for my username and password? I want to make sure you guys like. So here, first of all, it needs your username and password. So you will put your username and password, then log in. It will ask you the way that you want to verify your account using Duo. So you can call or enter a passcode or send me a push, which is the easiest way that I like to use. So I got the push notifications right now, and I will approve it. So I recommend you guys, like all of you, like follow me step by step. So I'll go slowly, and if you have any problem, just or any question, you can put it on the chat, and hopefully we will help you as soon as possible. So everyone is able to log into their Open on Demand or Crane Open on Demand. Please put yes, and if you have any trouble, like put no. So I can see most of you guys like were able to log in successfully. So once you have successfully logged in, you will be directed to your Open on Demand dashboard, which displays the message of the day, as you can see in here, and the menu bar and the top of the window. So you can see there's a menu bar over here. So I will go through each tab in the menu bar, and we'll see what we can do with Open on Demand. So first of all, like as you can see, I'll start from the top right button that you can see. It's a logout. It's obvious. So you can log out from Open on Demand from Crane. If you log out, if you click to log out. So as you can see here, like you will see here logged in as your username. So you can make sure that's your username. So, and you are using your, credentials to log into Open on Demand. There is a help button over here. Help button is kind of, a very good way if you need the support, it will redirect you for, like HCC, our, contact. It will provide our emails, but the most important one is HCC support at unl.edu. If you have any problem, you can, open a ticket and email us, and we will get back to you. So if you go to the help, there is an online documentation. The online documentation is, I recommend each of you guys and everyone, just like, go and read the documentation. It will give you like a very good, overview about our cluster, how to submit jobs, how to run open on demand, everything like you need. Mostly like you can see it in the documentation that we provide. Also, in the help, you can change your password. So when you have a new account, like you were asked to change your temporary password, and you change your password, if you need to change it again, or you forget your password, so you can change it using this link here. If you click on it, so you will redirect to a web page that will, you can here, put your username, and maybe like you can reset your password if it's needed. So here's a refresh. I'll just like restart with server. If you have any connection or any browser issues, it will, just help you to refresh the web server. And that's all about help. So first of all, let's go about, open on demand. There's a Crane open on demand that's, will indicate we are using or logged into a Crane cluster. And the open on demand here, like Crane open on demand, anytime if we click to this Crane open on demand, it will bring us to this page or to the main page again. So if we go like use one of the tabs, or we have been like somewhere else in the open on demand, so and we want to go back to the main page, so we just need to click like Crane open on demand, and it will bring us back to the main page. So there's a tab called files. Like since we are logged in the Crane, so you can see here there is a main three type of directories that we can access. The home directory, which is when you log in to the shell command or to the terminal. When you first log into the using your credential, you will be in your home directory, and which is like /home / your group name / your username. This is where it's your home directory. So, and then after that, there is a work directory. You can access your work directory as well. So you can switch directory to your work directory, or there is a common directory, which is the common, which is accessible from both clusters, Crane and Rhino. So for example, let's say like I wanted to go to my home directory. I can just like click to home directory. It will open a new tab. And this tab will show us, all the files and, the directory tree for my home directory. So as you can see, you will see like something different. It depends on how many files and directories do you have in your home directory, but you will be able to see them like in all of the files, like as I can see here. So I have all of those directories and files in my home directory. And you can see here is the tree. For example, I have, for example, like master, for example, data shell. Most of you like they have data shell. So here we're gonna work. So if I want to enter this directory, I can click on data shell, or I can double click on data shell over here. So this is the way like how you can see and access your files. So the thing is, I want to talk about first of all. So here you can see there is a show.files. So if I remove the click in here. So I think you will see it removed in your Open on Demand. So this is like, as we mentioned in the previous or the first, session of our workshop. So we said there's like files, it will begin by dot, which is usually a configuration files for your applications. So which is the hidden files. Usually it's a hidden files. So those files, if you can even, see them by click to the show.files. So if I click in here, I can see all the files that will start with dot, which is hidden files. So it's just like one way sometimes if you need it or you don't. On the other hand, there's like show owner mode. So do you remember like when you see or show the files, like we use the command ls, right? But here we can use like also there's an option ls dash, for example, ll, right? Which gives us more information about the files that we have. So like show owner files and the mode. So as you can see here, it will expand some more information. For example, who's the owner, when's the last modified of the files and directories. And here it can indicate the size of the files, if it's a file, and it will indicate it's a directory if it's a directory. So here it's the directories that we have over here. And here's the files and the size of the file that I have in my home directory. The mode, which is the permission that we have on the files and directories. For example, this file we have read, write. The first one, like R is read, W is write, and X is execute. So in this file or this directory, I have read, write, execute for the owner. And read, they don't have write, and they have execute for my group members. And they have read, and they don't have write, and they have execute for the other and the word. So it's a good to have, those, permissions to know, like in your, files and directories. So, okay. So now let's go. I want each of you go to their data shell directory, which is, you have it, guys, because we used it many times in mostly like most of the sessions. Then there is, directories and files inside of it, right? There is a creators, data, etc., right? So those are directories and those are files. So for example, if I want to, let's say, view a file. So for example, I want to view pizza.cfg, right? So, or notes.txt. So let me view this file. Can I view it like using Open on Demand? Yes, we can. Using the button, as you can see here, it's a view. So if I click to view, as you can see, this is the content of the file. So instead of doing like in command line, cat, so we can, just view the content of the file. So if I want to edit this file, so view will not give you the permission to edit this file. It's just like for viewing the file. If I want to edit this file, I need to click on the file and maybe like edit the file. So I click to the edit here. It will open a new tab. And as you can see here, I have the ability to edit it. There is a good thing actually about, Open on Demand. So it recognizes this is a text file, and I can, play with the, size of the font size, for example, or the theme. And here is like the mode. The mode is like sometimes if I want to edit like a programming file, for example, C++ or, for example, any like maybe PHP or, XML file, or for example, VHDL, which is, one of the hardware programming languages. So I can use, like move, or I can change the mode of the text that I'm working with. So for example, here, let's change this file. For example, And let's add hello, or let's say welcome to HCC. Sorry. Okay. So after I finished editing this, so here I missed probably like parentheses. Then after that, I'll save it. So after I saved it, so as you can see, this is a new tab. Everything you do like editing is going to be a new tab in your browser. So I can close it. So this is the notes. So if I view it again, so you can see like I already edited this file. Okay, so I can also rename or move. So I can rename this file and move it, which is equivalent to MV command in the command line interface. So I can, let's say, rename it. So if I want to move it, like now I am in the, as you can see here. So this is the path that where I am right now. I am inside my home directory, inside data shell directory, right? So this is the path. So I can write the path. For example, I'm here. If I want, for example, to move this file to my home directory. So I can do dot, for example, right? And if I want to rename it, let's say like notes1 instead of notes dot text, right? So, and let's see, okay. So now, as you can see, it went from my current directory to my home directory. So here I can go back to my home directory by clicking to here, for example. So it went back to my home directory, and you can see there is a notes1.txt. So if I view it again, so I can see this is the same, file I was, moved and renamed. Okay. I'll go back to data shell directory. So now we know the view, edit, rename, or move, and I can download the files. So it's an easy way to download files from your current, for example, desktop or current computer to your, HCC account. So if I want to download the file, I just click download. If I want to download the file, so I want to download the file from my HCC account to my, for example, computer, to my local desktop. So sometimes you have some files you want to transfer. You can use Globus, you can use a CP command, even though you can use Open on Demand using graphical user interface, right? So if I want, for example, to download the BISA or solar.pdf, so I'll just click to the file that I want to move or to download. I can select more than one file, by the way. So I can just click to the command and select more than one file, for example, to download. So for example, I want to download solar.pdf. I'll download it. So as you can see, it's downloaded right now. So here's the file. So as you can see here, so it downloads solar.pdf to my local machine. So as well as I can copy. So for example, if I want to copy this one, so I can copy it and I can paste it. For example, if I want to paste it here, it will say path is same. So that means you are trying to copy and paste the same file at the same place. So I want to copy it somewhere else. For example, if I want to put it in my local directory or my home directory, I just do paste. Now it's pasted and now it's over here, as you can see. Okay. So now I went to data shell and data directory, for example, and I can select all the files. If I want to select all the files, as I said, multiple files by using the command key, as you can see. If I want to select all the commands, so I can, just select all. So just select all, for example, here. So it will select all the files that in the current directory. If I want to delete some of the files, right, there's a remove command, right? So if I want to remove sunspot.txt, I just need to, select the files I want to delete and just, click to the delete button here. Always be careful when using delete because you can't, get them back. It's really hard. So delete. So it will ask you, are you, really want to delete the selected file and the name of the file? If you select OK, then you will remove this from your, HCC account. So another thing from here, so as you can see here, you can go to, when you go to, like, it will, if you want to move between your, directories or go to a specific path you want to do, or you want to go like to that path. So you need just like, to write the path. When you click to the go to button, is gonna like, show your current directory right now. Right now I am in data shell in the data. If I want to go back to the data shell, I just need to write it, or some other paths. You can write other paths. So I move to the data shell right now. Again, you can open a terminal. This is one way to open a terminal. For example, if you want to open a command line or shell command line, a window, you can click on it. And boom, we are inside the current directory that we opened, the terminal. So we were in the data shell, right? I was in the data shell over here. So if I do pwd, so I don't need to, log in again because I already logged in to my account. So it will give me a shell window that if you want to work with the command line as well. So, and as I said before, so here, as you can see, it's my, the path that I was in. Okay. Any questions up to now? You can as well, like, for example, in here, I can create a new file. If I want to create a new file, I just create a new file, name a file, for example, file1.txt. Okay. Then, okay, it will create this file to me in the current directory. And if I want to add some data, so I can edit it and I can work on it. So hello. Okay. Then I save it. I close it. Then after that, if I want to view it again, so as you can see, we edit this file. If I want a directory, right? If I want to create a new directory, which is in the command line, make directory command, right? So I can create a directory here. So I can create new directory, for example. So it will create this directory for me. I can enter inside this directory. I can, create files or move, copy, whatever. You can manipulate your, files and data as needed. Another thing is I can upload. So here I can upload any of the files that I want from my current desktop to my HCC resources. For example, now I'm using Crane. I can download a file from my computer to Crane. We can use SCP, right? As well, we can use Globus, and we can use Open on Demand for doing that. But usually, like if your files are really big, we don't recommend this, using this method. So we will choose a file. So I'll choose one file, for example, the one that we already downloaded, right? We want to upload it again to our HCC resources. And then we choose this for upload, and we can see it as here. It's already uploaded to my current directory. So any questions so far? So I want you guys to follow me, and, if you have any questions, just let me know. Okay. We closed that tab. So we already went to the files. So you can do it the same in your, for example, like in your work directory or common directory. So if I want to go to my work directory, so as you can see right now, I am in my work directory. Okay. So something else you can work with, which is the job, job lists. On the, the second tab, let's say it's a jobs. Jobs consist of two things. You can see active jobs and you can see job composer. So this is a very useful and helpful actually thing in Jupyter, Open on Demand. As you can see here, like the active jobs, if you click to active jobs, what's going to happen? What are we going to see? So here you can see all of your jobs that are submitted to the cluster. If it's, for example, running or deleted or, failed, so you can see them here. Since I don't have any of the jobs, so I can see it here, it's, like empty. But there is a tab in here. So it says your jobs, because I don't have any jobs. So it's empty because I don't have any jobs submitted to the cluster. But here you can see all jobs. If you click to all jobs, as you can see, we can monitor all of the jobs in the cluster, but you don't have permission for them. For example, if I want to, delete this one or whatever, since I am not the account owner, or this is not my account, so I can't, I don't have permission to do anything, but you can view them for sure. So this is all, for example, jobs that are running with the cluster. You can show them like all of them, or 50 per page, or 25, etc. And here, as we logged into Crane, you can see the jobs that are running on Crane. So if you want to see the jobs are running on the Rhino, you need to log into the Open on Demand, the Rhino Open on Demand. So as you can see here, the job ID, the job name, the user, the account, and the time used. This is the name of the queue, and this is the status. So for example, this is a completed job, this is a running job, and this is a queued job. The good thing is you can, for example, search or filter those. For example, based on, for example, status. If I want to do in the status, I just need to click on the status. It will show me, the completed, then queued, etc. So it will, group them by the status. If I want to do it, for example, by ID, so this is ID ascending, as you can see, from the least ID number to the largest one. If I want descending, for example, I need to click ID again. So it will show me or, sort all of the jobs in descending order based on the ID. So I can search, for example, if I want to search, for example, by using job ID, for example, for this job. So I can filter using the filter here. So I can put the job ID, and you can see here is this is job ID, or the job that is, qualify the constraint that we already put, which is, the job ID. If I want, for example, to find all jobs by this user. As you can see, this is all jobs just by this user. So this is really useful. So and this is how we monitor the jobs. So this is how we can, see the active jobs and, running jobs, completed or queued jobs on the cluster. Okay. I'll close this tab. Now, the other part of the jobs is the job composer. Job composer is very important because here's where you can create jobs, submit jobs to the clusters. And it gives you a template that you can, it's be helpful, because every time you want, for example, to submit a job to the cluster, you need, for example, for specific applications, you need to write, the script file to submit this job on the cluster. So here's like we provide an open on demand, some templates that you can use that will make your life easier to submit jobs. As you can see at the beginning, when you open the open on demand on the jobs tab, you can see here like here is, for example, like steps to create a job. It will give you kind of hints or step by step how to create job, which is useful. Like as you can see here, we need to, if you want to create a job, we need to create a new job by copying from an existing job template directory or previously run job directory. So if I have, so I can create two kinds, like for example, two ways to create a new job, either by like new template or by existing job template that already I have. Then we can edit the files that we need based on the job that we want to submit to the cluster. Then we need to submit using the job composer. So we will submit our jobs using job composer thing. So if we click to the next, it will give you, for example, the first thing you need to do to create a new job. So let's create a new job first. So a new job, we will click a new job. So you will have like these options. If you click like from default template, it will give you like a very basic template for a job. So we will see. So as you can see here, it will give us like a general job. This general job, the name of it, general job, and this is the time it's created, and the cluster name is Crane, and it's not submitted yet. So as you can see here, there is a job details on the right of the screen, and this is the name, and this is submit to Crane. You can't change anything, and the script location. This script will be located in this is the path where it's going to be located in your account. And the script name, you can change the script location, and you can change the script name as well. So you can name it as, like, for example, any name like you want to do. Then when you are ready, you click to submit this job, or you can click delete to delete this job. So I'm going to delete this job. I don't want, because I want to submit other jobs. So just to give you an idea how to create a general job. So I will delete it. So then it's deleted. So I will create a new job. Again, I will do it from a template. So if I do from a template, so as you can see here, so, okay. So you can see here a list of templates that we provide, and each of them is provided by probably like specific applications. This is like one of the applications called like Abacus, MPI job, or Blast, or Fluent, or Games, MPI, or GrowMax, GPU, etc. Or Gaussian. So it depends. Like sometimes if you are using one of those applications, it's easier to use one of the ready templates that we provide to submit a jobs. So you can see there is like, it will show like the first list is gonna like 10 templates. Then if we go to the next page, for example, there's a MATLAB job. If you want to submit a MATLAB job, or for example, Python or R or SAS. So those are like ready templates that we provide in Open On Demand. So let's do, for example, like a Python job, right? So Python is very popular, and just to test it and to submit jobs to the cluster. So we will go to the Python job. The name of the job is Python job. So let's rename it. So we can rename this file, for example, let's say we will do it like our first job. Let's say job 1, okay? The cluster is a Crane, and the script name is python.submit. This is the script name, like that will, include how many process, like cores, the amount of memory you want to submit to the cluster, etc. And as you can see here, there is a template location. This is the template location. It's not located in your directories or in your HCC account, because this is a template. This is for everyone, right? And you can open the directory. So you can open the directory here and you can see. It will give you an Python example, like we can view it. Again, this is not in our like home directory or work directory. This is located in work, HCC, Open On Demand, apps, my jobs, templates, Python job, because this is a template. This is for example, hello world.python. This is the program. We can view it. And can we edit it? We can't even edit it because we don't have access to it. So if I try to edit it, so let's say instead of 60, we will put, for example, 10. So an error occurred, attempt to save this file, because this file is not found. As you can see, we can't edit this file because it's not owned by ourselves. And you can see here, like there's a YAML file, and there is, this is the submit script. So as you can see, it will provide you format or like, a ready submit script that you can already submit to the cluster. So if you want to change it, you can change it. I'll let you know how just in a little bit. So as you can see, it's requested 1 nodes. Number of tasks per node is 1, 5 gigabytes. The time is 10 minutes, and this is a job name, and this is the error file name, which is Python job which is here is going to replace by your job number .error, and the output file is Python job which is the %j replaced by your job ID .out. We have module purge, which will like clear all of the models that we already have or loaded to our account. Then we will need to load Python 3.8 model. So because our program we want to run is Python, then this is the command line to run it's gonna run hello world.python, which is the file we already have. So, which is hello world.python. This is the file that we want to execute. So I'll close this one. So this is just to open the directory. Then after that, here we created the job, which is same as those files, but it's going to be our job. It's not going to be the template job, right? So we'll create a job called job 1, and we will create a new job. So as you can see, after we create this new job, so this is the job that we have. And as you can see here, job was successfully created. So we already create this job. So I can go over here. So where is the script location? Now, as you can see, the script is located in my workspace. So it's in work. This is my group name. This is my username. You can see it in Open On Demand projects default 1. So let's go and check those. So if I go to files, I'll go to my work, right? So in my work, I need to see, because it's dotted, right? Show dot files. So dot open on demand, it's in projects, default 1, right? Project default 1, that's true. So as you can see here, so it has a hello world.python and python.submit. So it's exactly the same as the template. So for example, if I want to edit this one, for example, python.submit, I want to edit it to have, instead of 10 minutes, let's do like, for example, the time limit is 20 minutes, for example. And you can, change the name of the output file or the error file, number of the nodes, how much memory you want. For example, I don't need 5 gigabytes, for example, I need 1 gigabyte, or for example, 2 gigabytes. Okay. And I can save it. So here I edited the submit file that I have. And if I want to change the program itself, so I can change the program, I can add my program or whatever you want. So for example, will go like 4 from 1 to 5. If it's 1, then it will print 1 minute has elapsed. If it's not 1, which is in the second loop, is going to be 2, is going to go to the else. 2 minutes have elapsed. 3, it will go to the else. 4 to the else, then it will print hello world. So instead of sleep after each loop, it's going to sleep 60 seconds. So we will put it like sleep 10 seconds. Okay. And then we will save. And we can, for example, instead of 5, we will do it like, for example, 10 loops. Let's say like 6, because it's going to take more time. So 10 is going to take more time, because every time it's going to sleep 10 seconds. So we will save it. And then after that, I'll go to the job composer. And the job composer, I need to submit my file. So in here, I need to submit it. So here you can submit instead of doing SBatch. This is the SBatch button, we will submit. So after we submit our jobs, you can see here the status is queued. So if I go to the jobs, and if I go, for example, back here to my jobs, as you can see here, your jobs, we'll see. As you can see, it's running right now. It's changing from queued to running. That means my job is running right now, and I can monitor my job. So we'll see. Now it's still running. So it's going to take probably like 60 seconds, because there is 6 loops, right? Or 6 iterations, sorry, in the loop. And each one is going to like sleep for 10 seconds. Now, as you can see, it's completed. So my job is completed. And this is the ID of my job. And where we will go, like, for example, if we go here and we refresh the page, you can see this is the error and the output of your program. And as you can see here, we have like in the python.submit, we name it as a Python job. And this is the job ID, or the job ID that I have, as you can see here, which is this one. Dot error and dot out. Let's see the dot error. Dot error, we should see it empty, which means we don't have any errors happen during running the application or running this program. And the Python job dot out, this is the output file. as you can see, there is a 5 loops. We start from 1, 2, 3, 4, 5. If it's 1 minute has elapsed, then after that 2 minutes have elapsed, 3, 4, 5, and then we printed hello world. So any questions so far? So as you can see here, this is my job. It's already now in my account. So I can delete it. I can, for example, if I submit the job again, I can submit the job again. So it's secured. I can stop the job over here. If I put stop job, so it will, now it's changed to failed. So because it's not running, or it didn't run completely. So because I already stopped it, which is the ask cancel. If you have like command line interface, it's equivalent to ask cancel to your job. So Yavuz, like you have, can we share a big data with another collaborator who is from another group in OOD? So yeah, as Emily said, there is like a Globus file sharing for that. So you can check our documentation and you will find more information for it. Okay. So everybody is with me and everybody is going okay. Sure. So if I want to go back to my main screen on Open On Demand. So as again, I said, like I click to create Open On Demand. So I went to the main screen over here. So we already navigated files and the jobs, active jobs and Job Composer. And there is a cluster here. The cluster tab will just give you an option to, open command or the shell command, window. So if I click to it, so it will go to your, we'll go to your home directory, and open a terminal. That's all. So this is another way to open a terminal. So you can do it from the Files tab inside your files, or from directly, if you don't want to navigate through one of those, you can go just to the cluster and open a shell directory from the clusters. Now there's an interactive apps button, and the interactive apps button, that means these are the, the applications that we can run using Open On Demand. So as I mentioned before, you can work on Jupyter Notebook or RStudio, or you can have, a graphical user interface desktop. So you can have like your desktop, or GUI for your HCC account. So let's go first to the desktop. If I click to the desktop, so here, like when you click to the desktop, it will give you this screen, which is like when you create a desktop, that means you are running an interactive job. It's an SRun. So you are running interactive job. So if you want to run, if you remember when you run an interactive job using command line, we specify the number of cores and how many hours we want to run this interactive job, and how much RAM we want to request for this interactive job. So it's the same, and the queue name as well, and the partition. So here in the desktop, you need to specify, you want your desktop to run using, for example, 4 cores, or 2 cores, 1 core. It depends, but there is a limit. The limit is like 8 cores per desktop interactive session. So here, for example, I request for 4. How many hours? I want to run it, for example, for 1 hour, and you have the maximum you can run it, which is 8 hours. How much RAM do you want to request? I can request just 2. Why I'm using fewer resources? Because it's going to be faster to allocate those resources from the scheduler. And the minimum here for RAM is 1 giga and the maximum is 32 gigabytes. So the queue type, there is a short. Short usually will, execute your interactive job faster. But there is a limit. So the limit there is like you can request up to 6 hours as a runtime and 2 jobs of 16 CPUs or lower. While the normal doesn't have this constraint. So there is a 2 queue, there is a normal, which is the normal that when you submit a job, it goes to the normal, usually if you don't have a specific queue, while you can use the short if you just want to run this for shorter time, And there is a partition selection. The normal is batch. If you want to run a GPU using a GPU resources, you can, specify GPU over on the partition. Reservation, if you have a specific reservation for your account, for example, we have some specific reservations for some groups. So you can, if you want to use them, you can input the name of your reservation. Grace here, if you want to use, here's if just you put Grace as GPU. If you want just to use the GPU resources. And here's the link, as you can see. Here's more information that you can see. It's exactly as interactive job. For example, here's the Grace. If we want a GPU, we want to specify is a GPU. And there is, for example, if I want a constraint, a specific type of GPU, for example, here's GPU K40, I need to specify that. So, sorry, I need to go back. Okay. So, and here's the constraint if you want to put, a specific type of GPU, if you want to request for GPUs. The email, it will, ask you about your email. It will notify, send you sometimes if you ask for big resources or bigger resources, your interactive session for your desktop is going to take, for example, a while to execute. So in this case, or to allocate resources to be specific. So here, like it can, send you an email when the session starts. And remember here, I ask for 1 hour. Then after that, I will click to launch. So after I click to launch, so you can see here, it's not allocated yet. Now it's, waiting to allocate the resources for me. So, and this is the time that I, request for the resources or run the srun command for the desktop. And time requested, I requested for 1 hour, and this is the session ID. So now, as you can see, now it's allocated. How I didn't know that it changed, and I can see right now launch desktop. So I can run my desktop right now to have the graphical user interface for my HCC account. So if I click to launch desktop, it will open, a graphical user interface, for your HCC resources. This is my home directory. If I double click, as you can see, this is all the files that I have. So I can move, copy, delete, like you deal with it in, like, for example, Windows and Mac operating systems. I can also, there's an application here, applications. I can open a terminal, work with it. Or for example, if you need like a web browser. So the web browser here is not working, but there's a Firefox actually, I think, internet. So you can see here Firefox. So For example, this is Google, so it's working. So you can view your, sometimes if you have a specific type of graphical user interface results you want to see, or deal with some of the applications. So this is the best way to do it. Okay, I will close this tab. So if you are done with it, you just close the tab. So as I said, this is an interactive job, which is one of my jobs running on the cluster, right, on Crane. So if I go to the active jobs over here, as you can see this desktop, or like an interactive job that I already ran, and it's running on the cluster, and it's going to be running for 1 hour, then it's going to be, canceled. So any job or interactive job you submit, you can also monitor this job like using your job composer or, jobs and active jobs, tab. So when I finish using this, I will close it. So we highly recommend, after you finish working with your, interactive job, to delete this one, especially because this will, reserve resources for 1 hour. If I finished, for example, in 10 minutes, and I don't use it anymore, it's still running. It's gonna, consume resources for 1 hour. So there is, for example, as you can see here, 56 minutes remaining for my session. So when I finish, using it, I will delete it. So we confirm this. So as I said, this is the first one, which is interactive desktop. And there is a Jupyter Notebook on the Jupyter Notebook or RStudio. So in the Jupyter Notebook, if I want to use a Jupyter Notebook, I will create an interactive session as well. It's the same process, number of cores, running time in hours. And this is max 8. This is max 8 cores, max 8 hours. The RAM requested. And partition, usually it's going to be a batch. The batch is the normal partition that you submit your job. If you want to use a specific partition, for example, like GPU, you need to specify the partition to GPU. And there is like just resources reserved for Jupyter Notebooks. So we have a queue or a partition, specific partition called Jupyter. This is just for Jupyter notebooks, sessions that you run on Open on Demand. So you can use Jupyter or batch or GPU if you are using GPU. And the reservation is as before. Grace, if you want to use GPU, you need to specify GPU. If you have constraints, a specific type of GPU, you need to specify it over here. And here is like to notify you with your email. If you want, you will click this one, this button or this checkbox. So let's launch this Jupyter Notebook and see how we can use it. So now it's allocating the resources. Again, as you can see here, now this is completed. This is the desktop one. So this is the desktop session or job that I submitted and deleted. So it's completed. And now this is running. So I should have it ready here. As you can see, you can connect to your Jupyter. So it's, changed from pending job to running job right now. So I can connect to the Jupyter. And this is the Jupyter Notebook. As you can see, I have an example over here, like in my, in my directory, I have HCC Jupyter example. I provide it to you guys as well. At the end, we will have it as an exercise. So this is the HCC Jupyter example. And as you can see, this is the Jupyter, example that I want to run. So it will open it. So I can run, for example, this is the program that I want to run. So I can run. And this is going to running. As you can see, it's running. This is going to be 4 from 0 to 7. And it's going to just print the number and just sleep half a second. And this is just for loop. It will print from 0, like it's 50 loops from 0 to 50. As you know, like in Python, like the loops start from 0. And as you can see, it printed this one. This one is like from 0 to 49. So here, every time is going to print 2 multiply. The first time is going to be the first iteration. It's going to be 0, which is 0 minus 1 is going to print minus 1. Then it will sleep 0.1 second. Then after that, it's going to be 1. Next iteration, 2.1, which is 2 minus 1 is going to be 1. Sleep 0.1 second. Then the second one is going to 2 multiply to 4 minus 1, which is 3, and etc. till 49. So let's run this. As you can see, it's running. And you can see the output. So as any IDE, for example, like here, you can have a new notebook, or you can open one, you can make a copy, etc. So all of these options, you will have it like in Jupyter Notebook. Okay. So when you finish it, I'll close it. I will leave this page. And then after that, because as you can see here, sorry, if I go to active jobs, as you can see, it's still running. So I need to delete it first, so I can delete it after finish using it. So now I have no active sessions. Okay. And if you refresh this one, both of them is completed. So another type of application you can use using Open On Demand, which is RStudio Server. In RStudio, if we click to RStudio, so we have 2 versions of R you can use. So we have 3.6 version and we have a 4 version release. So which one you want to use is okay, it's up to you. So if I want to use, for example, 4, I'll choose 4. And in 4, actually, there is different types or like variant for this version R. So we offer also all of those variants. So you can choose any of them. But in 3.6, I'm not sure. So it's also as well like in 3.6 and 4. So we have like those variants. So number of cores, I want 2, number of time in hours, 1 hour, requesting RAM, 2 gigabytes. So I'll run it on the short queue. But this will give me 6 hours maximum to run and 2 jobs, up to 16 CPUs or less. If you want to use more, like you can use the normal, quality of service type. So partition is batch. I can use GPU if I'm using a GPU. I need to specify that. So if I have a specific reservation, so I can include it here. So if I'm using a GPU, I need to specify the Grace GPU. And if I need a specific type of GPU, I need to specify it over here in the job constraints. I can write my email if I want to notify when this session will be start. And I just click to launch. So still waiting to allocate the resources. Now, after it allocate the resources, you can see the session ID and the time remaining as well. And here in the specific version of R, you will have your username and you will have your password. The password is required to log into R. So you need to copy the password by clicking to this button and then log in. It's your username and the password that I just copied. As you can see, the previous R, okay, because I opened the previous R session before, so this is not important. So now, as you can see, I'm logged into the R version 4. So let's do some very simple, let's say commands. Let's assign a, for example, 40. And maybe a capital letter with, let's say it's a multiply 3 minus 20, for example. And we can see, for example, print, let's print A. If we print A, what's gonna happen? We will see 40. If we print a capital letter, then we'll see it's going to be 100. So which is 40 multiplied 3, which is 120 minus 20, which is 100. So this is like an RStudio that you can use using Open on Demand. You can't have this, I mean, like, as easy as using it in, for example, if you want to use it on a command line interface. But you can have like a plain R, which is the command line for R as well. But for example, Jupyter Notebook, you need to, like it's better to use it using Open on Demand thing, which is gonna make our life easier. So after I finish from this, I just closed it and I can delete my session. Confirm. Does it come with all the libraries pre-installed? Yes. And if you have any specific libraries, you can install the library yourself. But everything comes in the cluster. It will come in the RStudio as well, the same version. Okay. So this is the interactive jobs. The last one is my interactive sessions. Here, like actually I missed it a little bit. So like when you create a sessions, if you, for example, create a session for R, a session for Jupyter, and a session for desktop. So if you click to my interactive sessions, here you can see all the interactive sessions that is already active in your, for your Open on Demand account. So do you have any questions? Okay, sounds good. Then the last thing I want to talk about, so I want you guys, I don't know if you were able to, follow me and, apply all things I already applied or like showed in this session. But I will recommend you guys, let's do a small exercise. I want you to, execute and apply the Jupyter Notebook example I already had. And I already put it on the GitHub. So using command line interface, download this file and, execute it using Jupyter Notebook. So I'm putting in your home, like in your work directory. So I'll put the link in the chat box. So for sure to download this, you need to use, like, for example, git clone, and then the URL. Sorry, the git is gonna be like, needs to be a small letter. So it needs to be like this. Okay. So please apply this one, try to run it, and see how it works. So I can do, for example, to do it, like I can go to the cluster, crane shell. So I'll open a shell, and as you can see, I am in my home. I'll go to my work directory. So this is all the files. I'll just rename my all the old example that I have. Okay. So then you don't need to do this step. So you need to do just git clone. And G is small letter. So I cloned it. I can do ls. I can see it, RCC Jupyter example. So you will go to your dashboard or Open On Demand dashboard. You will go to interactive jobs. You need a Jupyter Notebook one. Again, you will specify how many cores, hours, RAMs, etc. Then you will create your Jupyter Notebook session. So now it's ready to connect to the Jupyter Notebook. It's ready to use. As you can see here, RCC Jupyter example. I'll go to it. I'll open this file, and I can run it directly from my session. So please put the check mark yes if you have done this successfully. You can try it anytime, by the way. So when you have this link for the GitHub, it's going to be open, so you can download it anytime. You can create your own. You can, use your R example, whatever application you are using, either R or Jupyter Notebook. And as I said here in the job composer thing, so you can create your job, you can modify it using a specific templates. We have around 16 or 17 templates for specific applications. So it's going to be most frequent used applications templates we already have. And that's all. Any questions? So yeah, I can see like many people who are like already have successfully, applied this example and got their results. So yeah, if you have any questions, you can ask, unmute yourself, or put your question on the chat box. And thank you so much, everyone. I hope you get all the goals you need to know about Open on Demand for this session. Thank you.